In a previous video, I had talked about the remainder of a series using the integral test. And as a reminder, the remainder, Rn, is equal to the absolute value of s minus Sn. S is the entire series, and Sn is the sum of the first n terms. When I dealt with it previously, I did not have these absolute values. However, that was because I was dealing with particularly positive decreasing series. Now that I'm dealing with alternating series and I can have alternate signs, we need the absolute values. So we have that S is going to be my alternating series, the summation of -1 to the k plus 1 times ak. Sn is going to be the sum of the first n of those. And when it comes to alternating series, our remainder is actually a little bit easier. We have that Rn is less than or equal to an plus 1. So the remainder is less than or equal to the first neglected term, or at least the absolute value of the first neglected term, since we're not going to consider the plus or minus. So let's look at an example of this. So I'm going to consider the alternating harmonic series, -1 to the k plus 1 times 1 over k. And I want to know how many terms need to be used to approximate the series with a remainder of 0.000001. So 5 zeros and then a 1. Well, first let's think about what happens in the n plus 1 term, since that's what our remainder is determined by. I know that Rn is less than or equal to a sub n plus 1. So Rn needs to be 0.000001, which should be less than or equal to 1 over n plus 1, since I'm not considering the sign, not considering the -1, just the 1 over n plus 1. We take the reciprocal of both sides to get 1 million is greater than or equal to n plus 1. Subtracting 1 from both sides gives us 999,999. So we need at least that many terms in order to get this to within this remainder. The next one I'm going to do, I'm going to look at the series that's the sum of -1 to the k over k factorial. And I want to know if I sum the first 10 terms, what is the maximum remainder that we could get? Once again, I know that Rn is less than or equal to a sub n plus 1. And in this case, n is equal to 10 since I'm adding the first 10 terms. So I have that the remainder is less than or equal to the 11th term. That tells me that the remainder is less than or equal to 1 over 11 factorial. And using a calculator to evaluate that, we get that R10 is less than or equal to 0.00000025. So this is a really good approximation with only 10 terms.